Bom dia a todos. Vamos começando para não nos atrasarmos mais. Bem-vindos a este segundo dia do Encontro Ciência 2019, que tem sido muito animado. Gostava só, antes de entrarmos na sessão e no tema propriamente de hoje, gostava de chamar a atenção para o facto de termos oradores também especiais para além dos cientistas, que são os jovens que vieram através da Ciência Viva e que convidámos para fazer pequenos pitches na entrada das sessões. Eu gostava de chamar a vossa atenção para o facto de que eles fazem parte do programa e ocupam tão pouco tempo e que são momentos que fazem a diferença para estes jovens e que certamente também vão todos gostar. Posto isto, vou começar a sessão de hoje, que nos traz aqui, que é a comemoração dos 50 anos da chegada da humanidade à Lua. And I will now switch to English because we have many English guests here today. So it is a great pleasure for me and an honor to moderate this session, as my generation was born with the space age. And we were kids when mankind first stepped on the moon. So being here today is quite fascinating. Also, space in our science center, space is still one of the most successful topics to engage the public with science and technology. And we do a lot of activities on space for students and also for the public at large. We do it mainly through our contract with the European Space Agency, ESO Portugal, but it is always a very successful in terms of the public that comes and the feedback that we have from the public and students and teachers. Also, the space industry is one of the fastest growing activities in Europe, creating thousands of jobs. So it is very important that we prepare our generations for space and for this economic activity that is so important for Europe. Europe leads in many fields of space, as you know better than me. So, but today, I would like to point out that contrary to what happened when I was a kid, when we were kids, where only the superpowers were able to reach out to space, then the space became, instead of a race for power, became a space for collaboration with European Space Agency. And now, more recent, a new paradigm has emerged, which is new space. And new space brings countries like Portugal, brings space to the reach of countries like Portugal. And our session will be about these new paradigms and the new national, and as you know, a national strategy about space, on space, has been delivered by Minister Manuel Heitor, and a space agency has been created in Portugal space. And like the caravel that you have seen at the entrance, we like to do it with others, and so we like to do it with friends. So today, we will start with Maria Cody, who is the president of the UK Space Agency, and then we will have Nick Vex from Satellite Application Catapult, also from the United Kingdom, and then we finish with Chiara Manfletti, who is the newly elected president of the Portugal Space Agency. So, Maria, you have the floor.
First of all, I'd like to start by saying how delighted I am to be here to speak about space on the occasion of the 50th anniversary of the moon landings. But I'd like to first start with a confession. I did not watch the Apollo 11 landing. Alas, not because I was too young, but because my family didn't own a television set and didn't know anybody else who had a television set. I was, however, lucky enough to watch the Apollo 12 landing because it was convenient enough that it happened during a school day, so I was able to observe the landing whilst a 5-year-old at primary school. So when I told this story to members of my family, including a 5-year-old, I was expecting their reaction to be, "Wow, you observed such a momentous point in our history." But no, I got, "You grew up in a household without a television set." And this really got me thinking, because if the Apollo landings happened today, rather than in the 60s and 70s, many more people would be able to observe it. Not because, of television set ownership, because they'd probably, witness it on something like this, wherever they were, up a mountain, in a forest, possibly on a train. And so my hypothesis of the legacy of the moon landings is that, yes, it was about a moment of inspiration in time. It was about man's ingenuity, but it was also much more. It was the start of space enabling us to live our lives better and to underpin so much innovation. Two US presidents who are closely associated with the Apollo program, I think, sum up this sort of dual dimension of space as inspiration and as everyday reality. I think we could all quote President Kennedy, who said, "We choose to go to the moon and do the other things, not because they are easy, but because they are hard." However, I imagine few of us can quote President Nixon, who said, "We must think of space as part of a continuing process and not a series of separate leaps, each requiring a massive concentration of energy. What we do in space from here on in must become a normal and regular part of our national life, and therefore be planned in with all the other undertakings which are important to us." So as part of the project in school where we watched the Apollo 12 landings, we were asked to draw a picture of what we thought the future would look enabled by space. I mean, fortunately, my artistic endeavours are lost to history, but I want to really focus on what should have been in that picture. I think from memory it was all robots and self-cleaning house, because I didn't like chores when I was younger. So this is really where I want to focus the next part of my talk. What should have been in the picture I should have drawn 50 years ago? So obviously, mobile telephony, communication, the connected world. I mean, telecommunications and broadcasting are incredibly important to the UK, and I was very fortunate enough to be talking to somebody from Goonhilly last night, which of course was at the heart of both the Apollo landings and also the start of transnational broadcasting for the UK. Also, in my picture, I would obviously have to put all the applications enabled by good connectivity. I would put e-health. I would also obviously have to put navigation in there. I personally enjoy being able to find my way from one place to another, but actually, perhaps more important is the innovation that this enables, including in things like driverless cars. And I looking over at Nick there, I understand that the Harwell campus is going to have its first driverless car launching this summer, which I hope to get a ride on. I think the other thing I want to talk about is how all these applications, when they come together, what they can do. We have applications such as precision agriculture in the UK, whereby farmers can use communication, navigation, and Earth observation data so that he or she can actually irrigate crops or fertilize efficiently, saving both money and protecting the environment. I think as well, we also have to look back 50 years and with the realization that the industrialization of our society has impacted on our planet. But again, space has a very important role to play in mitigating the impacts of climate change. And I have to say, Earth observation could be the new telecommunications sector in the UK. It grew 25% in our last survey up to 2018. So, in the golden age, to summarize, space has enabled us to undertake and have services and products in our everyday life that we couldn't imagine 50 years ago. But back again to inspiration, I still think we mustn't lose the fact that space can inspire us as nothing else can. When I started work for the UK Space Agency, one of the first highlights of my job was to go to our science museum and observe the launch of Tim Peake to the International Space Station. I was in the museum with 2,000 young people, and I have to say, I think Tim would have heard them in the International Space Station without any use of modern communication technology. Indeed, then, back again to my experience of the Apollo 11 landings, 24 million people in the UK observed Tim's flight to the ISS. And perhaps equally or more important, 1 in 3 of UK schools took part in projects or engaged in activity associated with his mission. And I know all the other European astronauts across Europe have seen a similar high level of engagement. I think walking around Lisbon, it's very difficult to forget that Portugal, like the UK, were leaders in terrestrial exploration and led the world. So in space, we are looking forward in the UK to continuing this collaboration with Portugal in exploring space. We are generally collaborating with Portugal, but in some cases we are competing. So in the UK, we have just started a spaceflight program, which is looking at satellite launch and suborbital flight from UK spaceports. So we see this as an exciting opportunity to thrive in the new space age. To date, we've spent 31 million to establish launch services from a new spaceport in Scotland, and we have recently confirmed our intention to support Virgin Orbit from Spaceport Cornwall. And of course, we are following very closely Portuguese plans for the Azores. The UK has been very clear that we are not stopping collaboration in Europe. Indeed, again, one of my roles in the Space Agency was to go to the 2016 ESA Ministerial, which was a mere 6 months after the UK EU referendum result. And we made a record contribution there, which signalled our intent to carry on collaborating with our partners all across Europe. This is incredibly important to us, and obviously we are starting now to prepare for Space 19+. So, looking forward to Space 19+, and my role is to prepare the UK's offering for Space 19+. Where are we going to put our money? So, I think looking at the European Space Agency, the jewel in the crown is undoubtedly their science programme. And I'm pleased to say that we've recently announced the Ariel programme, which again has a very strong collaboration between the UK and Portugal. Again, this is a legacy from the Apollo landing. When Neil Armstrong looked down on the Earth from the moon, he observed that it was 50 times brighter than the moon. And it's right that the next study should be the study of exoplanets through the Ariel programme. Thank you, Anna. Where else are we going? So I've spoken a bit about exploration, and delighted that ESA will be offering a brand new exploration programme, looking to return to the moon in collaboration with NASA, and then on to Mars to do Mars sample return. On telecommunications, there are parts of the world where you would be unfortunate that you couldn't watch the Apollo landings today because of not spots. I'm told that on the train from London to Paris, about the only place you get assured signal is under the channel, not on the train. So we look forward to the 5G revolution, so users will be able to have connectivity irrespective of whether it's provided terrestrially or from space. Future generations are demanding we take action now to mitigate climate change, to ensure the health of the planet. So, excellent that we carry on seeing a very healthy Earth observation programme. The UK, as part of this, have asked for European partners on the Truths mission that will step up to the challenge of providing an international calibration standard, and this will be linking our National Standards Laboratory, NPL, NIST in the USA, and BIPM in Paris. We're also looking at the flagship space weather mission to Lagrange Point 5, and we'll carry on underpinning technology and navigation, and we might even look for ESA for commercial launch. But please don't report that we're suddenly going into the Ariane 6 programme, because we're not, and I'll get myself into complete trouble. So before I finish, I just want to say we are seeing an unprecedented change in the space market, with the role of government evolving, and it will become more normal to simply purchase goods and services from the private sector. And I think this new space revolution offers us a very exciting opportunity. I think you'll be relieved to know that this is the end of my speaking note, but before I go, I just want to say, innovation in engineering in space underpins our future, and it will only happen if nations continue to pool their knowledge and creativity. Thank you so much for inviting me to speak today. But more, thank you for all of you who work in space, for enabling me in my day-to-day job to go back to those moments of awe and wonder that take me back to being a 5-year-old girl watching the Apollo landings. Thank you.
Bom dia. That's all I can speak in Portuguese, I'm afraid. Obrigado. I perhaps could order 2 beers, but I'm not sure that will work here. So thank you very much for the invitation. Thank you, Minister, and thank you to colleagues in FCT and all the organisers for the invitation to speak today. It's a really great honour. So I'm going to pick up on some of the themes that Maria spoke of in her excellent introduction here, and perhaps give you some illustration of some of the satellite applications that she alluded to. Let me just see if I can work. Technology. So I did watch the Apollo 11 mission at 3 o'clock in the morning on a small black and white television set. I'm a little older than Maria, and we were rich enough to have a black and white television, or chose to have a black and white television. Actually, the Apollo mission, which I recall at least as much, was Apollo 8, which happened at Christmas in 1968. And I remember to this day Borman, Lovell, and Anders, the 3 astronauts who were the first human beings to leave the confines of Earth's gravity and travel around the moon and back again. And this quote from William Anders, I think, it was very important. I had this poster, this picture was on my bedroom wall as a little boy. I was so impressed with what I saw then. And he said, we went all the way to the moon, but the most significant discovery made was the Earth. And I'm going to pick up perhaps on 1 or 2 of those themes here. Oops. Why is that happening? Now I can't read the Portuguese. That one? Good. Someone out there helped me. So our view of space now is changing. It's not just something we look at and are inspired by, but it's actually useful. We actually use space, or we use satellites in space, in our daily lives, and many of us don't think about it. We begin to take it for granted. We can see, of course, the whole hemisphere of space, and we use these sorts of images for weather forecasting, to monitor the climate, and to monitor all of our environment. But of course, we can also zoom right on in, and perhaps you'll recognize this image. This was taken just a couple of months ago by the Worldview 3 commercial imaging satellite at a resolution of about 30 centimeters. And indeed, if we zoom right in, we can see where we are. We can see, of course, we're used to seeing pictures on Google Earth showing our back gardens and our cars and houses. But of course, the issue with Google Earth is the imagery is often quite old. But of course, nowadays, with modern constellations of satellites, we're beginning to be able to update much, much more frequently, even to the extent that nowadays, if we're lucky, we can get imagery like this, which is at, again, better than 30 centimeters resolution, but actually this shows streaming video from space. You can see the aircraft flying along the bottom. I'm not sure if the light is good enough, but in the top right and the bottom left, you can see cars moving on the highway. This was taken by a North American company, Earthcast, based in Canada. And this sort of imagery is now available. This is Dubai, of course, if you can probably recognize in the center the tallest building in the world. And you can see its shadow, and it's moving as the satellite flies over the top. The building isn't moving, of course, it's the satellite that's moving. There's just repeating the plane flying by. So that's live video from, well, it's not live now, but at the time it was live video from space. So looking at how do we get here, really? How did we get to these satellite applications from where we were in the 1960s? I like to think of that really as, if you like, the first space age. Here it was about inspiration, it was about exploration, it was the great race to the moon between the USSR and the USA through NASA. And we moved through the 70s and 80s, perhaps into the second space age, where it's becoming slightly more commercial. We began to see commercial telecommunications, broadcast satellites, point-to-point telecommunications with companies like Inmarsat and later Sky, and Intelsat, of course, as an institutional provider. So we went through this where we were beginning to move away, or move alongside space as exploration, but also the usefulness of space in our daily lives. And now we're moving perhaps into a third space age, maybe, where there's much, much more disruption. So nowadays, space is not only in the confines, as we heard from Maria, of institutions, of large countries and organizations like the EU, institutional space, but increasingly it's becoming a mass market affair, where satellites, some of the first satellites that I worked on would be almost as big as this stage. So the ESA Envisat satellite is as large as a double-decker bus. It's as big as this stage. It cost hundreds of millions of euro. But now we have satellites which are as big as the laptop in front of me and cost just a few €100,000. And that makes it open. We can have now constellations of satellites. Obviously, they're not as functional as the massive and expensive satellites, but used cleverly, they're able to deliver very useful services to us here on Earth. And this gives us a point in our industry now where we're perhaps at a bit of a discontinuity, where we have the mature, large organizations, the multinational aerospace companies who have been building satellites for many, many years with exquisite detail, beautiful satellites with magnificent engineering, with great delivery of services. But they're being challenged by this new space of tiny little satellites being built, not, almost in your garage out the back garden. It's not quite like that, but it's very, very similar. And it's very challenging for them to navigate themselves through this discontinuity in the industry. But of course, on the other side, it's great opportunity for investors through even like crowdfunding and investments in the city to put money into these new ventures and to challenge and bring new services. And what we're seeing is a connection between launching and building satellites and actually delivering the services from them. Whereas that used to be two rather separate things, now the same organizations are able to develop services with recognizing a market need and then build their own satellites. And it's a very, very exciting time. And it was with that background, really, that the organization I work for, the Satellite Applications Catapult in the UK, came to pass. For the UK recognized that there was an opportunity here for businesses to try to do something new and different. I'll speak just a little bit about that more in a moment. So what do we mean by satellite applications? Well, there are basically three things: Earth observation, communications, and navigation. And all of us use these things every day. Every time we see a weather forecast, we don't believe it unless we see the satellite picture of the clouds going over. All the time now, we're watching our sport and our news through satellite television. And of course, as we come into a status of 5G, we're seeing satellite being embedded into that communications infrastructure. And of course, again, many of us will have come here today, whether we came from abroad or from other parts of Portugal, using satellite navigation in our cars to help us find our way. And these things are coming together now and creating great, great opportunities for us. So who are we, the Satellite Applications Catapult? I think it was the Director General of ESA who, when he came over to the UK to open our facility, he said, "A catapult, is that some new UK invention for a low-cost launcher?" But no, it's not. It's just catapulting science into business. And indeed, in Portugal, we have the co-labs, which are offering a very, very similar service, bridging that gap between science and business. We are benefiting from some government investment, but we're independent of government, which gives us much, much more freedom to choose which investments we want to make, which companies we want to back, and how to pull that science through. So as I say, catapults and the co-labs in Portugal here sit in this space between universities and industry, bridging that gap, bridging that so-called valley of death, where it's very hard to get funding for new innovations. You can get funding for fundamental science, you can get funding from the banks for very close-to-market product development, but that gap in between, known as the valley of death, is very, very difficult. And again, collabs and catapults are there to bridge that gap. So moving back to Earth observation satellites, this just shows on the left-hand side the increasing spatial resolution. So as we move towards this sort of 30 centimeter or better at the top of the picture, but on the horizontal axis, we see the frequency of images. And we've been used for many years for something like Landsat where you get an image, if you're lucky, once a week or once a month, or even less if it's cloudy, which it is most of the time in the UK. And the resolutions, of the order of 10 meters or so. And then we moved into these commercial satellites in the top of the picture there, usually American, coming from their previous spy satellites, essentially, but also in the UK, in France, and in other countries here, in Europe, where we are able to offer commercial services at, a meter or better resolution, maybe as lucky as once a day. But the exciting things now are over on the right-hand side, where we see the Flock 1 satellites. That's from an organization called Planet Labs, who operate more than, I think it's getting on for 200 CubeSats with imaging on, which means that you get more than daily pictures. So again, if it's cloudy, that's not much help, but in areas with little cloud, you're able to get updates on a daily basis. And it's really that top right-hand picture of the diagram where we're all aiming. Those are where where we see the new commercial applications are coming. So most of those satellites are creating images in the optical region. So whether it's in the visible part of the spectrum or in using infrared. And what we're seeing there in this nice color picture, this is actually Berlin, is a sensitivity to the chemistry of the surface you're looking at. You're seeing color. You're seeing something about the makeup, the mineralogy, if you're looking in deserts or somewhere, but you're seeing the chemistry and the structure of what you're looking at. Of course, nowadays, we're very lucky to also have radar imagery. The beauty of radar, of course, is it can see through clouds, it can see at night, so every time a radar satellite flies over, you're guaranteed to get a picture. But radar's a bit different. It's a bit more difficult to understand, a bit more difficult to interpret, and the sensitivity with radar is to the dielectric of the surface. So it's to do with surface roughness, it's to do with the moisture content, and it's to do with the structure of the vegetation. In this particular picture, which is where I work, this is Harwell near Oxford in the UK. The strange thing in the center, the circular thing there, is actually a synchrotron, which is run by our Science and Technology Facilities Council. And we see the buildings in the science park at Harwell surrounded by vegetation. And the coloring in this picture, of course, it's false color from a radar image, is showing that when things change, you'll get a different color. So as the crops are growing, the different crops, the structure of the crops changes in a different way, and you're able to distinguish different crops from each other simply by this change. And you can get the same sort of detail, better than a meter spatial detail in the areas of infrastructure. So we're used now to putting these sorts of images and the optical images together, along with in situ data and other data sets, to develop services. And if you see the sort of figures we're looking at here, there's now really an open data revolution, starting from a few years ago when the USGS made Landsat imagery free. On the left-hand side, if you just look at the change in when they made those Landsat scenes more available, these are millions of scenes downloaded. And I hope you can see we're up to the sort of 50 or 60, probably up to 100 million by now. And then on the right-hand side, we see that here in Europe, ESA operates a whole constellation of Sentinel satellites. And they're expecting something like 25 petabytes of data. And these data are now opening up services for commercial companies and organizations to develop. We live in this age of big data. And data, like oil, is only interesting when you refine it. Data are just pictures. They're just pictures to hang on the wall. But once you start to integrate and fuse those data, add artificial intelligence and analytics, then you can turn data into information. And we are now connected. We're much more connected than ever before. And again, as we move from this time of just selling images to selling information, we're able to operate in many different markets. So Earth observation technologies, we're particularly interested at my organization in all these. We have programs looking at how to help industry develop new services in all those sorts of market areas. But perhaps more exciting is working on a global stage. These are the Sustainable Development Goals, and really satellite communications, satellite imagery is becoming important in every one of these. And so by working in this global, if you like, for the good of the planet and the good of the community, we're hoping to be able to open up commercial applications as well. Perhaps one example of that is some work that, again, my organization with partners around the world has been doing in South America. You may remember a few months ago there was a terrible disaster when a mine in Brazil collapsed and the tailings dam went into a nearby village. We had been working, in fact, in Chile for 2 years before that, looking at a number of mines in Chile, and we're now working with the Brazilians to introduce a secure system for monitoring these sorts of facilities. We're able, through the Earth observation, to look at the slopes and to add those together with other information about the land surface, with in situ information, to create models of how these structures are moving and to highlight, hopefully before the event, when there perhaps is something more dangerous. We also work with, again, small companies in the UK. This is actually London, but it's looking at heat vulnerabilities. We've just had a major heat period in most of Europe, across France and Germany. And of course, in cities, we get these so-called heat islands, where the heat can build up during the day to quite dangerous levels. And satellite is providing one component of measurements into that. In more detail, this is another picture of Berlin. This is actually the railway station in Berlin. This work has been done by our colleagues at the Deutsches DLR in Germany. And the picture at the top are point targets measured by satellite radar of that station in Berlin. And if you measure those point targets over a period of a year, you can see the movement due to the thermal movement over these are seasons. So obviously this is greatly speeded up. It's almost like it's breathing as it grows and shrinks again over a year. And we can do that with infrastructure such as bridges and large buildings, and actually see the movements and again gauge the safety of these sorts of things. Again, entirely from satellite. Putting satellite together with ground data, this picture is actually looking at air pollution. This is an area in Leicester in the UK. And these companies are small companies of sort of less than 10 people who have acquired the satellite data from the Sentinel, the ESA Sentinels and other places, merged it with data from the city council about the movement of traffic, and created models which they're now, the urban council is now able to use these models to determine how to switch traffic lights on and off in order to be able to move traffic away from particular areas at certain times of the day in order to improve the air pollution. So I'm coming to the end. So really I want to look into the future now. And these are the sorts of technologies that are becoming very, very important. So although we're the satellite applications catapult, we're also interested in the technologies, working with other European partners in small and large companies, looking at these new technologies to see what sorts of things can deliver. And I'd like to finish now with a short video, just a 5-minute video, and I want you to think really now of the future, of the sorts of, the picture that Maria painted when she was 5 years old of what might the future look like. When will that future be? I remember I used to think we'd all be driving around in hover cars. So let's just have a look now to think, when we made this video 2 or 3 years ago, and we were looking forward to 2030 as our target. What will the world look like in 2030? And here we are in 2019, and already this video is almost out of date. There are 2 or 3 things in here which we thought were at least 15 years away, which we're beginning already to see. And please enjoy the video.
Good morning, Prof. How's life in the Arctic today?
It's busy. 14 cargo ships on the China Path in the last 3 days. Lots more fishing boats too. We can see the cod stocks are up.
How's the new strain of oil eaters getting along?
Alcanavorax 17 is the one. Satellite shows good growth rates and we're getting on top of the league. So I'll be home next week.
At last. That's great news.
I know. I'm actually starting to dream about bacon sandwiches. Can you make sure that there's some nice food in the fridge when I get back?
Done. The fridge is talking to the supermarket right now.
Oh, what time are you leaving for Bristol?
Oh, 5 minutes.
Good luck. And don't forget Jack's present.
Hello, Tom. Please state your intended destination.
Hotel to Van, Bristol.
Estimated arrival time, 10:21 a.m.
Good morning, Hotel to Van.
Hi, I'm coming down for dinner tonight. Is it going to rain at 8 o'clock?
It's looking rather lovely all evening, sir.
Perfect. In that case, we'll meet outside.
Certainly, sir.
Call Aziza. Hi, Aziza. I'm on my way to Bristol now. Looking forward to seeing your presentation later. I hope you can join us for the contract signing afterwards.
Good morning, Dr. Jones. What can we do for you?
Hi. That book I bought last week. Can you send another one to me this morning? It's rather urgent.
Should we send it to your current location? Hotel Demand?
That would be great.
Of course. We have one available. They'll be with you in 40 minutes.
Thanks so much.
You're welcome.
Good morning, ladies and gentlemen. Personalized medicine production is a major industry here. But what you see now is our new MRSA antiviral crops. This used to be degraded land, polluted by mining works decades ago. But we mapped the worst areas and reclaimed the rest. Now it is a very productive site. Each host plant is tagged and talks to us, of course, so we know how well it's growing, what it needs, and when to harvest it. Our production is up 34% from last year already. Thank you, ladies and gentlemen, for listening to me.
Mom! The school set is on land! Come and see! Come and see!
Okay, darling, but hey, look at your blood sugar levels. You need to eat first, okay? 50 grams of carbs. Go!
Call car.
Do you wish to amend location?
Come to the hotel immediately.
Dr. Jones.
Hi, Tina. I've just had the alert about Mr. McKendrick on the solar power orbiter. I don't want to wait any longer. Send the STEM design files to their main bay and ask the team to prep for an implant now, please.
Certainly, Doctor.
I'll screen in from the car. This is Dr. Jones requesting screening to the medical bay solar orbiter.
Thank you. You are joining the theatre now. Dave.
Good afternoon, Dr. Scott. The patient signs are good, so please feel free to proceed when ready.
Well, guys, we are all set. Next up, the Brave New World. Speaking of which, did you remember, Tom?
Of course, something for your collection.
Thank you. I love it. Look at this. Personal hover cars. So when's all this futuristic stuff going to arrive then? I can't wait.
Thank you.
Good morning from my side as well, ladies and gentlemen. So we've heard this morning already how much space can enable the future, and some of these messages are messages that I will strengthen also in my talk. And this is actually why I've picked the title as it is. We used to sort of send messages up from Earth to space. Do you copy? To satellites, to people that were up there. Now space is talking to us, and we should listen, and we should make sure that space is even more integrated than it is today in our daily lives. We heard from Maria and Nick about the moon. I wasn't born, unfortunately, so I couldn't experience that. I'm certainly looking forward to what's going to happen again on the moon. But as some people say, let's not go back to the moon, let's go forward to the moon, let's do it differently this time. It started with a race in space, as Maria and Nick were saying. It was a race between superpowers to show that they could sort of do something and demonstrate their sovereignty. You probably know that the first heroes were not humans, but they were animals. We sent up a chimpanzee and a dog from the US and Russia. What you perhaps don't know is that in Europe we also sent up an animal. It was a cat. As a side note, they had actually picked, and this was France, they'd picked a male cat called Felix. And the day before his launch, he decided, he probably read some newspaper saying it's dangerous, and he decided that it wasn't such a great idea, so he disappeared, and it was Fizzy Set who was then set up instead. So if anyone wants to interpret anything into that, I allow you to do that. We've come a long way, and now we're exploiting space a lot more. We have the International Space Station, where nations collaborate. Unfortunately, it's just a selected few, and I think we should look forward to enabling even more collaboration. We've heard how much space is changing, how many more actors and partners are being involved, and nations and actors should enable a much broader collaboration. What do we do on the International Space Station? We do lots of research in very many different fields, from molecular biology to gravitational biology, fluid physics, material science. There's lots of things which are done which enable then technology transfer on Earth. And this is why I was saying space is talking to us. Space is enabling many different things. And we're putting also platforms in space that allow small companies or even universities to put up their experiments for relatively low cost, and then take these experiments back and see what's happened. Now, there's also a very interesting experiment which was done. If you're interested, you can read further. There's twins from NASA, and one was sent up to the station. He stayed about a year in space, and one stayed on ground. And what they did is that they examined the changes in the genome and all sorts of other characteristics in the two brothers. And much of what we learned has helped us understand the human physiology. One of the first ones, it's regarding telomeres, sorry, pronunciation. Telomeres are the protective caps of our genes. And what is thought is that these protective caps, they get shorter and shorter as you get older. And the thought was that by measuring the length of these, you could tell how old a person is. Now, by examining the twin that was in space, we realized that these telomeres were getting longer during the stay in space, and were longer when he landed again, and afterwards got shorter than they were before he left. So this has also changed a bit of our perception on how the human body is functioning. Now, the reason why I'm bringing this up is that we've heard a lot about what space is doing, and certainly one of the things that's helped us in our exploration of space is trying to support the human body in space. And telemedicine is one of the things that has come out of our exploration of space, and this is something that we certainly can find applications across the board in the world, in remote places where we don't get so easily. But imagine in the future where you don't have to go to the doctor and sit for an hour waiting for your time because it's just a cold or it's something minor. And you could take advantage of telemedicine, for example. Certainly for the more complex elements, we would still want to have some human contact, but there's certainly advantages that we can take out of it. Yesterday, we also heard some very interesting talks about gravity, about exoplanets, and what I'd like to do is also show you some of the spin-offs that we've had from the scientific advancements that we've gone through. So we've heard about the special theory of relativity. We know that time is slowed down when we're traveling at very high speeds, and unfortunately, it's not something that we experience on ground, but if you're in space and you're a satellite, you do actually experience it. And we also know that time is slowed down due to gravity, as time-space is distorted. So what's the actual benefit for society? And we know today that our navigation systems would not work if we didn't have this knowledge. Actually, it's quite interesting. If you calculate the time difference between these two elements, it's only 382 picoseconds, right? It's not very much, but it would cause a navigational error of 500 meters in an hour, which is enormous. Now, in Europe, we've invested into a global navigation space system called Galileo. And by the way, if I may mention, it's 3 times better than GPS. So please throw away your old phones and get new ones, because that's where Galileo is integrated. We heard, however, yesterday that you shouldn't leave them at home, but do invest in recycling. So yeah, please do use Galileo. And talking about phones and about the precious metals that are in phones, and the talk we heard yesterday about recycling materials, we do face resource issues on Earth, and certainly in situ resource utilization of space assets is certainly going to be one of the advancements that we should look into. Now, I was traveling back yesterday from the wonderful event that our UK colleagues organized, and I saw a placard, and it says, "There is no planet B." And it's actually not quite true. We heard yesterday about exoplanets. There are many planet Bs. The question is if there is one for us, which can be lived, and if we can actually have the technology to get there. But that's not the point. The point is, even if there are many planet Bs, we shouldn't waste what we have here. Our planet A is the most beautiful place in the universe, and we should conserve it. But in any case, looking into in situ resource utilization is something we should do, not to bring the resources back, but to make sure that space becomes part of the socio-economic sphere of influence of the Earth, right? Extending what we can do. We heard yesterday about black holes and how this is also going to change our understanding of the universe and how it came into being. We heard about one specific mission, but there's 2 other missions that I'd like to mention, and one is Athena and the other one is Lisa. One is an X-ray telescope, and we'll be able to look at hot gas structures and supermassive black holes. And the other one is Lisa, with which we'll be able to look into gravitational waves. And we heard about yesterday what gravitational waves are. If we have a big, massive body which moves or accelerated, there are gravitational waves that move through the universe, and we can detect them. Now, by putting the information that we get out of these 2 missions together, we can understand more of the universe and look into black holes, dark matter, and dark energy. Why am I mentioning this? We heard yesterday all about periodical table, and this is just another depiction of our elements and where they originate from. Some come from the Big Bang, some others come from exploding massive stars, some from emerging neutron stars. And the question is, how do black holes play a role also in this? So we'll probably have to write, and I hope rewrite the textbooks with the knowledge that we've gained. Sita mentioned yesterday about water and are looking into where the water comes from. So I won't repeat what she said, but indeed there was one mission that ESA designed, and that was to Churyumov-Gerasimenko, the Rosetta mission, to look into if the water on the comet is the water that corresponds to what we have on Earth. And she mentioned yesterday that we look at the ratio between the light water and heavy water, and we know that on Chury, there's 3 times more heavy water than there is light water. And therefore, we know that at least this comet, or all comets we heard from her yesterday, are not responsible for the water on Earth. Now, as we were designing this mission, and this is why I'm mentioning it, we had to design a camera to see, to depict or visualize the comet. And comets, as she's mentioned yesterday, they're very dark, so they're black, dark gray, lighter gray, so 50 shades of gray. And what we had to do was develop a camera for that. Now, this camera has been technology transferred to another field, and it's now been placed in woods. And because it can detect these variations in black and gray, and it can actually distinguish between something which is just water vapor or smoke. So this is also where space technology can help us on Earth. And now we're in Portugal, and we know all about how important and how dramatic the impact of forest fires can be. And certainly one thing that I'd very much look into in the future, and I was talking to the minister about this yesterday, is how can space even more contribute from risk mitigation or risk identification of forest fires all the way to recovery. And of course, and we heard it from Nick as well, different applications or different satellite platforms can provide different revisiting times, different resolutions. So the question will be, it's going to be about asking the right questions. What do we need during which phase of tackling the topic of forest fires? Now we're hot, so it's forest fires, and let's move to another hot element, and that is the sun. I just want to talk about the sun a little bit. You know, the sun goes through cycles of about 11 years where we have high solar activity and low solar activity. At the moment, we're at a solar minimum, and when you look at a solar minimum, there's not very many solar spots, right? But when the sun goes from one solar cycle to the next, the polarity of the solar spot switches, okay? So this is the polarity of one solar spot, which is on the sun's surface at the moment. And in this picture, you can actually see the white and the black spots, they reverse in position. And this tells us whether we're gonna go from one solar cycle to the next. Yesterday, we heard about knowledge being power. Now, I find this kind of knowledge is just pure bliss. It's absolutely fascinating. But why am I talking about the sun? Another thing that has been transferred from space are solar cells. We develop solar cells for applications for satellites, and this is now being transferred, or has been successfully transferred to Earth, and we heard about it yesterday as well, how we can integrate and even develop new materials to make solar cells even more successful and integrate them into recyclable energy. One of the other things that the sun nicely provides for us are the auroras, the northern lights. Now, this is the nice part. What we also sometimes forget is that the sun does coronal mass ejection, so it spews lots of high particles towards the Earth. It takes about 3 to 4 days in normal circumstances for these high particles high energy particles to reach us. However, if there are several coronal mass injections, one after the other, these particles can reach us as fast as 15 hours. That's extremely fast. Now, why is this a problem? It's a problem because if it hits us really bad, it can do very many bad things. We had the Carrington event in 1589, I believe, which caused fires in telegraphic institutions. And in 1989 in Canada, it destroyed some transformers, putting a part of Canada out of light and energy. Now, solar weather can cause lots of other bad effects on infrastructure, from astronaut radiation. It causes differences in the density of the atmosphere, which obviously plays an impact on our Galileo system, and therefore we need to know about that. It causes increased radiation doses in aviation. It can cause errors in directional drilling, and I mentioned the problems that it causes with power grids. So we need to keep an eye on this, and I believe that this could be the next Copernicus. With Copernicus and with weather systems, we monitor the weather and the conditions of our atmosphere, and I believe that space weather is going to be the next one. There are very many other impacts that space weather can cause, and this is one which I found particularly interesting. During the Vietnam War, about 30 marine mines just spontaneously exploded because of a strong solar weather event. So this has impacts beyond what we could possibly imagine. There are things that we don't know of yet. We heard from Maria that ESA is planning a mission to L5, Lagrange point 5. Why? The sun turns like this. And from L5, we can see what's happening slightly earlier. So we can do better forecasting of what's coming. Now, in addition to doing better forecasting, we should also invest into better nowcasting. So one of the things that we could explore as a Portugal nation is to develop some small satellites to put in orbit to do even better nowcasting, to support all the applications that we've heard about from Nick and navigation elements as well. Now, I've just mentioned the weather, and space weather is part of it. Now, we should never forget that actually, where did we learn about climate change? Where did we learn about global warming? We didn't learn from observing our own planet. We learned about it by observing Venus. And this, again, is where exploration and science have significantly contributed to our understanding of our own planet. And that's why space is part of the solution, and it should be even more part of the solution. Space can be integrated to information we get in situ and from the air to provide big data that we then transform into information. And I believe that one of the biggest breakthroughs in space came as we realized that space can provide data and information. And I believe that the next breakthrough is when we realize that space is not just about observing, but proactively doing something about all the global challenges that we're facing. In Portugal, we've come up with a space strategy called Portugal Space 2030. And this is a lot about research, innovation, and growth, economic growth, capacity building, investing into Earth observation and applications. And now I'd just like to mention a couple of those lighthouse projects, as I call them. One of them is autonomous shipping. I believe this is going to be something extremely important both for civil and for defense applications. Did you know that 85% of the international trade by tonnage is through shipping? We all know that there are changes also in terms of global warming, and we could certainly see autonomous shipping not being used not just across or between countries as we know them, but even looking for new routes to optimize even fuel consumption. One picture that I particularly like is this one. It's not actually a satellite image. It's an image of all shipping routes through the automatic identification system. And if you combine this with images from satellites, we can actually find and identify hijacked ships or things like illegal fishing and other elements. Now, this will of course require, and we've heard about this already, ubiquitous connectivity. And this is also where space can play an important role. And we've heard about the importance of safe and secure communication, so quantum cryptography. And for that, we will need to develop optical communication, and it will be extremely important to connect the whole world with one another through optical communication provided by satellite. So that's one lighthouse project that I'd very much like to explore in the future with you. Another one, and we've heard about it a lot, is sustainable development. And sustainable development, not just of our planet, but also of space. But looking first to our planet itself. We know that we get lots of information from satellites to look at the climate, and I don't know if you all know, but there's 50 variables that have been defined called essential climate variables, and these 50 variables are used to understand climate change and observe our system. And of these 50, 26 can only be observed from space. That's wonderful. That already shows how important space is. We've heard about soil moisture and other elements from Nick, but there are other elements that we could look into. For example, there's a satellite now called Aeolus, which is looking at the profiles of the winds across all altitudes of the atmosphere. Why not use this data and increase the kind of data that we get of this sort to optimize energy and invest into reusable energy sources? We've heard of the use of radar information to look at the breathing of buildings, but why not use this information to predict natural catastrophes from happening? We have volcanic eruptions that happen around the world on a yearly basis. We can actually measure how the Earth's crust moves up and down, and we know that this is an indicator on whether any volcanic eruption will happen sooner or later. So why not look into all of these elements and provide additional safety and security to our society? Another thing that we could certainly look into, and we've heard about this a little bit, is development of drought-resistant plants. We know that climate change is affecting many places around the Earth, and one experiment on the International Space Station shows that in the absence of gravity, plant roots develop even more quickly towards water sources because there's an enzyme that allows them to do that, and gravity sort of breaks them a bit from doing it. It stops them a bit. So why not stimulate this enzyme and develop plants which are even more resistant to drought and make the visions possible that we saw in the video just now? Looking into plastics is certainly something we've heard about a lot. Plastic has become a horrible topic for everyone, and we should certainly try and ban as much as we can the use of plastics. Trying to detect the plastic distributions from space is a certain element we should look into, but as I was saying, it's not just about observing, it's about then actually proactively doing something about it and making sure that our whole ecosystem is sustained. For the ecosystem in general, measuring things like sea surface temperature is certainly important. We have a wealth of data from the satellites that we have already in orbit at the moment that we could exploit even further. And my message here is, in addition to exploiting this, the information that we have now, we should also look into additional services that we can provide and that we don't envisage at the moment right now. Developing smart cities and cities which allow humans to have also a good life, not just very busy and very tiring for everyone, is something that we should look into. And for example, urban noise distribution is something that we could also look into. by using both, again, information from space, but also in situ and air information. Looking into coastal erosion is something that unites many countries around the world, and something that perhaps we could do together, Maria. But the underlying message is, we've seen that there are many user needs that are not being addressed today. And how do we, using space, how can we address these more? And the key is to diversify the instruments that we have at hand. History has shown that success lies in having as many instruments as possible at your disposition and knowing which one to use when. Space, as we've seen so far, has invested much energy in the big satellites with low revisiting times but high resolutions. Let's look into diversification, investing into smaller platforms, looking into high altitude platforms, and diversifying the set of instruments that we have at our availability. By that, we of course will not just address different user needs, we'll create new markets and have even more economic growth. And part of this is, of course, realizing that access to space is the fourth dimension of transportation, and we should look into definitely democratizing the access to space. And this is something that Portugal is doing, but many other countries as well. We've heard it from Maria as well. We are doing it through the Azores International Satellite Launch Program, where through a competitive dialogue with industry, we're trying to understand what it is that industry has as an ambition and to try and make that possible. Where? Well, if you haven't planned your holidays yet in the Azores, please do so, because this is what we're looking at the moment. And you see in the picture, the Azores are in the middle of the Atlantic, and therefore they provide quite some flexibility in terms of the orbits that we can reach, and especially looking into orbits which are sun-synchronous, which are good for Earth observation activities. Now, all of this could not be possible if we don't invest into new technologies and innovation, and one of them, for example, is artificial intelligence, certainly for Earth observation. So having intelligent satellites, but also investing into artificial intelligence for earthly applications. I mentioned the sustainability of our environment on Earth. It wouldn't be complete if I didn't mention the sustainability of space. And what we see here is a distribution of some of the elements in orbit. Here it's bigger than 1 meter. If we go into 10 centimeters, the number grows. If we go to bigger than 1 centimeter, then the number grows yet still. So we definitely have to address the topic of debris. We are becoming more and more dependent on space assets, and we should become even more so, but we can't do that if we don't start taking care of what we have in space. At the moment, we have some regulations that say we should bring objects down within 25 years. Imagine that someone said to you, your car doesn't work anymore? No problem, just leave it on the side of the road for 25 years, someone will take care of it. This is how we're dealing with it at the moment. It's not responsible. At ESA alone, we have about 1,000 conjunction notifications every day, and ESA's fleet is big, but it's not that big. And this should really get us to think. Future large constellations have been announced, and we've seen SpaceX launch some of them. And these companies aren't really thinking about doing much about their debris. If you talk to them, they tell you, yes, well, with so many satellites, we can go down to a reliability of 90%. So it means that 10% of their satellites are going to fail. Now, if you have 1,000 satellites in orbit and 10% of them are going to fail, well, okay, I'll let you do the math. That's pretty scary. I was mentioning artificial intelligence, and this is also another place where we could use artificial intelligence. We will be accumulating more and more data through programs like SST and other programs in terms of what is up there, and we're going to get really scared as our resolutions go up. And one of the things that we should do is invest into artificial intelligence analysis of the databases so that our satellites can more quickly understand if there's a collision risk approaching. So this is also one of the fields that we should look into. Now, my talk has come to an end. Hopefully I've shown to you some of the things that we could do in the future, which are very exciting. And now I'd very much like to get you involved in Portugal Space itself. The agency has been founded 3 months ago. It's all very exciting. Everyone in Portugal is extremely enthusiastic about space. So there's 2 things which I've done. One is we've launched a logo contest. So please, if you have an idea of a design, this is going to be your agency. So please do submit logos, and we'll be closing this at the end of August, and then there is going to be a winner announced on the 5th of October, I believe. And the other thing is vacancies have come online. So if you're interested in joining the big adventure and doing so through Portugal, please do look online. portugalspace.pt careers, and we'll be looking forward to working with you. Now, my final message goes to the community at large. We are here talking about science, celebrating knowledge. Knowledge is bliss, and knowledge is diverse. And my last message is one of diversity. Diversity not just in us people in the room, but diversity of knowledge. And one of the most wonderful message I find comes from Mahatma Gandhi, who said that our ability to reach unity and diversity will the beauty and the test of our civilization. So let's make the most of everything that we know and everything that we don't know, but will learn in the future. So thank you very much. Portugal is in space for you.
Thank you, Chiara, for this very inspiring talk. Thank you to our speakers for the talks. I am sorry to have shown you some colored cards, but it's because we will now have the Minister of Science and Technology, Manuel Heitor, and Commissioner Carlos Moedas coming to the stage.
Muito boa tarde, muito bom dia a todos. Nós vamos agora começar esta parte final. Certamente que o Comissário Carlos Moedas não precisa de apresentações especiais, mas é certamente um privilégio para nós todos e para mim em particular poder apresentá-lo hoje nesta sessão, ele que tem sido um participante ativo em todos os últimos encontros de ciência. De facto, o espaço, que é o tema desta sessão e que este ano comemoramos o 50º aniversário do homem na Lua, tem sido ao longo de muitas gerações, muito antes de 1969, inspirador ao longo dos séculos, também para o desenho de políticas científicas. E o próprio movimento, há 50 anos atrás, de pôr o homem na Lua, foi um ato também de políticas públicas e de política científica. E hoje, de facto, temos um leque, como foi bem demonstrado aqui, de aplicações, possibilidades. Os próprios extintores que hoje temos em todas as nossas salas, extintores de fogo, foram testados na Apollo há umas décadas atrás. E é esta realidade que o espaço transforma, que também sabemos que as políticas públicas, nomeadamente de ciência e inovação, podem transformar e estão transformando as nossas sociedades na Europa. E certamente o Comissário Carlos Moedas tem contribuído no contexto europeu, sobretudo para o desenho daquilo que foi hoje já uma realidade, a concepção do programa Horizonte Europa para o próximo quadro comunitário, também inspirado na ideia de missões e de provocar a Europa e, sobretudo, a relação entre os investigadores e a sociedade com grandes missões para a Europa, entre muitas outras áreas, desde a formação de recursos humanos, há, efetivamente, capacidade empreendedora na Europa através da formação do Conselho Europeu de Inovação. E, de facto, muitas destas lições advêm também daquilo que aprendemos no espaço e como o Nick aqui também explicou, e depois com os resultados, quer da Mary Code, quer com a capacidade empreendedora que a Chiara nos está a induzir, como é que nós podemos também criar as novas indústrias do espaço que vão certamente, esperamos, transformar a Europa e certamente no caso português, termos cada vez mais uma Europa com mais Portugal e um Portugal com mais Europa e por isso, em associação com a nossa Estratégia Nacional para o Espaço, definimos uma ambição de duplicar no próximo quadro comunitário a participação portuguesa, estando a trabalhar hoje com uma rede europeia entre a Fundação para a Ciência e Tecnologia e a Agência de Inovação, exatamente nesse contexto. E por isso é um privilégio e uma honra para todos nós termos e podermos contar com o Carlos Moedas, que depois desta sessão plenária estará também numa sessão paralela a falar sobre especificamente o Conselho Europeu de Inovação. Carlos, muito obrigado.
Muito bom dia a todos. Em primeiro lugar, muito obrigado, Sr. Ministro, meu querido Manuel Heitor, obrigado por tudo. A Sra. Comissária da exposição, o excelente painel que aqui tivemos. É um grande gosto estar de novo, mais uma vez, aqui neste vosso encontro nacional com a ciência e a tecnologia. E queria vos dizer que estou muito contente e, ao mesmo tempo, com uma certa emoção de estar aqui por 3 razões que vos queria contar. Primeiro, queria vos agradecer aos cientistas portugueses que nos últimos 5 anos tanto me ajudaram. E esse agradecimento é devido uma vez que será a última vez que aqui estarei como comissário, e aquilo que eu fiz como comissário dependeu muito daquilo que todos também fizeram por mim. Agradecer a imagem que, como cientistas portugueses, sempre deixaram lá fora. A imagem de abertura, de diversidade, de tolerância, que é aquilo que nós somos portugueses, e isso sempre me ajudou como comissário durante estes tempos em que tive este privilégio. E essa imagem é a imagem daqueles que estão dentro e aqueles que estão fora. Ainda me lembro com a emoção que recebi a notícia quando soube que o melhor, ou o cientista do ano na Áustria, era um português do técnico, o Nuno Maulide. Saber que essa é a capacidade nossa, dos cientistas em Portugal, que muitas vezes e durante tantos anos que a vida foi sempre tão difícil, de mesmo dentro das dificuldades, termos os melhores do mundo em todo o lado. Mas, sobretudo, o trabalho de cada um daqueles que estão aqui durante estes 3 dias. Pensar que, quando em 2014 cheguei, falava-se na altura de Portugal ter recebido como contribuição do programa Horizonte, antes do Horizonte, o programa Quadro anterior, à volta de 500 milhões de euros. Hoje, já ultrapassámos os 700 milhões de euros recebidos por Portugal e vamos, sem dúvida, chegar aos 1.000 milhões de euros. Olhava também para o número de bolsas do European Research Council, que duplicámos nos últimos 5 anos. E esse foi o grande trabalho. Não é o trabalho de um ou do outro, mas é o trabalho de todos daqueles aqui que estão aqui e que lutaram por essas bolsas internacionais e que fizeram algo que é muito mais do que a ciência, não é? Que é conseguir que Portugal passe da 2ª divisão para a 1ª divisão. A 2ª divisão na Europa é e serão sempre os fundos estruturais. A 1ª divisão são os fundos da ciência. E quem ajudou Portugal a passar dessa 2ª para a 1ª divisão foram vocês, aqueles que estão aqui. E esse, eu acho que é o grande papel que no futuro nós vamos sentir, foi que essa passagem de Portugal foi feita pelos cientistas. Segundo, porque devemos celebrar em conjunto aquilo que foram estes 5 anos e naquilo que conseguimos na ciência europeia. Pela primeira vez, e com a ajuda de Portugal, sempre presente, conseguimos pôr em frente ao Parlamento uma proposta histórica. Pela primeira vez, conseguir pôr uma proposta de 100.000 milhões de euros para os próximos 7 anos na ciência europeia. Nunca tinha acontecido. Uma proposta bem recebida por Parlamento, mas mais do que isso, conseguir em 3 meses negociar, tanto com o Parlamento como todos os países, essa mesma proposta e conseguir concordar com tudo antes das eleições europeias. E então deixar esse legado, que aquilo que poderíamos estar hoje ainda a discutir já está acordado antes mesmo deste novo Parlamento, é uma grande vitória para a ciência europeia e isso foi graças a esse apoio que sempre senti aqui neste meu país, que gosto tanto e que sempre que venho me sinto cada vez mais português. Mas há sobretudo 3 iniciativas de que me orgulho muito. E essas 3 iniciativas que vos queria deixar, e peço desculpa de hoje fazer aqui um bocadinho um apanhado de tudo aquilo que foi feito, mas às vezes também precisamos de celebrar um bocadinho aquilo que fizemos em conjunto. Penso que há 3 pontos, 3 iniciativas que ficaram e ficarão para mim sempre na minha memória como algo de mudança do sistema atual. A primeira foi a criação de um grupo de 7 cientistas-chefe da União Europeia. Até, basicamente, é esta Comissão Europeia, os políticos europeus tomavam decisões e essas decisões muitas vezes não tinham qualquer base científica. E aquilo que nós conseguimos instituir na Comissão à volta daquilo que nós chamamos o Colégio dos Comissários, onde tomamos as decisões, de ter evidência, prova científica para todo o tipo de política, isso não existia. E nesses 7 cientistas-chefe Temos uma portuguesa, a professora Elvira Fortunato, temos um prémio Nobel, temos pessoas extraordinárias por esta Europa fora que têm dado essa evidência científica aos políticos. E isso é muito importante para a Europa, é muito importante para os países, porque as políticas públicas têm que ser feitas com base nessa evidência científica. Quando tivemos a crise das emissões de CO2 dos automóveis, nós estávamos a preparar legislação na Europa. E essa legislação estava a ser preparada da mesma forma que sempre fizemos. E foi este grupo de 7 pessoas que conseguiu transmitir aos políticos que, no fundo, o caminho que estávamos a seguir não era o correto. Porquê? Porque os automóveis eram testados em laboratório, mas aquilo que eram as emissões são as emissões na vida real, quando o automóvel está na rua. E como é que nós conseguíamos medir essas emissões não só no laboratório, mas também quando os automóveis estão na rua? E isso foi o grupo destas 7 pessoas que trouxe como input para mudar a legislação, que não existia antes. Isso enche-me, de certa forma, de orgulho, porque é importante para a vida futura e é importante para a maneira como se faz política em todos os países, mas a Europa tem que ser o exemplo disso. Em vez de estarmos a distanciar-nos por ideias e ideologias, conseguir ter ideias e alternativas, mas todas com base na prova, na evidência científica. E esse era o primeiro ponto que vos queria deixar. O segundo, que vamos falar mais tarde numa sessão paralela e que vos convido, tem a ver com o Conselho Europeu da Inovação. A ideia de que quando cheguei em 2014, tínhamos realmente, e temos o melhor do mundo em termos de ciência fundamental, temos as bolsas do European Research Council, mas não tínhamos nada de paralelo ou nada de equivalente na inovação. De dizer que a inovação deveria ser feita à volta do inovador e não da inovação. Que a própria maneira como financiávamos tinha que ser feita com base nas ideias e não em tópicos. Isso foi uma grande mudança. Conseguir mudar a maneira não dirigista, de cima para baixo, mas de baixo para cima, em termos do financiamento da inovação. E depois que precisávamos, e muito insistiu o nosso ministro Manuel Leitor, que precisávamos ter financiamento não só para aqueles que eram os usual suspects, aqueles que já sabem como é que funcionam, aqueles que têm os consultores, que fazem as provas, que isso tinha que mudar. E mudámos 2 peças fundamentais, porque às vezes na política as coisas que é preciso mudar são muito óbvias e muito simples. A primeira é que para receber dinheiro para a inovação nós temos que entrevistar as pessoas. Temos que falar com o inovador, não é o dossiê. Fazer um dossiê muito bonito com um consultor, isso todos podem fazer. Mas ter a entrevista, mostrar aquilo que somos, é uma peça essencial nesse financiamento. E só para vos dar um exemplo, quando fizemos essa mudança, mudou tudo. Porque muitas pessoas tinham um dossiê muito bonito, mas quando eram entrevistadas não correspondiam àquela proposta. E outras tinham uma proposta que era média, mas quando eram entrevistados eram muito superiores à proposta. E esses eram aqueles que nós queríamos financiar. E, portanto, o Conselho Europeu da Inovação, um bocadinho como o European Research Council, que há tantos anos atrás foi criado, eu espero que daqui a 10 anos possa estar aqui nesta vossa conferência e que o European Innovation Council seja também uma instituição europeia respeitada em que conseguimos financiar a inovação de uma maneira diferente. Mas o que me leva hoje e que me traz aqui foram realmente a primeira oportunidade de estar a ouvir estas apresentações extraordinárias. E a terceira ponto que vos trazia, naquilo que eu gostava de deixar depois de 5 anos de trabalho, é exatamente este sistema das missões. Não é? E gostei tanto de ouvir aquilo que se passou neste painel, porque a ideia de missões e de espaço está tão interligada. Não é? Aquela ideia, e eu penso que a Mary falava nisso, sobre a ideia do Kennedy. E reparem como o Kennedy dizia I want to put a man on the moon, não é? E eu querer pôr um homem na Lua, essa mensagem era muito mais do que a ciência. Era essa ligação com as pessoas. Era esse ligar entre a pessoa e a ciência. Porque, no fundo, tudo aquilo era muito mais do que pôr o homem na Lua. O homem era a história. O homem faz parte da história que queremos contar. E nunca mais me esqueço que durante estes anos fiz uma grande amizade com um homem que muitos conhecem, que é o Bertrand Piccard, que fez pela primeira vez a volta ao mundo num avião solar. E o Bertrand Piccard dizia-me que a mulher, desesperada nos últimos dias, porque achava que aquilo não ia funcionar, dizia-lhe: Bertrand, mas porquê é que tu vais? Manda o avião sozinho, telecomandado. Dá a volta ao mundo, faz na mesma. As pessoas querem saber é se o avião pode dar a volta com energia solar, sem fuel, à volta do mundo, mas não precisam que tu estejas dentro do avião. E o Bertrand disse à mulher: não, porque se eu não estiver dentro do avião, não há história. Não é? E é interessante porque o Nick dizia assim: eu lembro-me tão bem quando a primeira vez que se foi à Lua, mas o que as pessoas se lembram foi quando pusemos o pé na Lua, quando o Neil Armstrong, quando o Buzz Aldrin puseram o pé no chão. E, portanto, a noção das missões, para mim, é realmente a noção de pôr o pé na Lua, não é? Porque é a noção da história. E, de certa forma, eu acho que deixámos de contar coletivamente a nossa história. Há 2 semanas estive num festival em Genebra, onde tive o momento dos meus 5 anos foi conhecer em pessoa o Buzz Aldrin. O Buzz Aldrin que 19 minutos depois do Neil Armstrong pôs os pés na Lua. E é interessante que eu perguntei-lhe que mensagem é que ele tinha para os jovens, o que é que ele diria aos jovens. Ele disse-me 2 coisas. A primeira foi: tell the story. Tell the story. Mas depois disse-me uma mensagem mais interessante, algo que eu conhecia pouco e que não sabia. Ele dizia-me: havia um diretor da NASA, nos anos 50, que a história que ele contava para inspirar as pessoas era a história de Portugal e a história do infante Dom Henrique. E contava nos corredores da NASA este homem que, no fundo, o infante Dom Henrique tinha feito realmente o primeiro projeto colaborativo da história da ciência, porque tinha posto os especialistas da ciência fundamental a trabalhar com os navegadores. E que isso nunca tinha sido feito. E que ele dizia, ele ia mais longe e dizia: the ghost of the Prince Henry is always there. Não é? E essa ideia de que essa inspiração na criação da tecnologia, da diversidade de pôr a ciência fundamental com aqueles que estão na prática, os navegadores, vem de nós, portugueses, e era contada na NASA como a inspiração, leva-me realmente a este ponto que, de certa forma, deixámos de contar a história. E deixámos de contar a história porque deixámos de contar que a Europa só foi grande quando tivemos no pico da ciência. Porque a Europa só foi o centro do mundo depois do infante Dom Henrique. A Europa foi o centro do mundo quando Magalhães dá a volta de circunnavegação. Antes disso, a Europa não era nada. E a América não era nada antes de, na Segunda Guerra Mundial, os refugiados cientistas se terem instalado naquilo que foi a grande obra da ciência na América, que foi o Institute of Advanced Studies em Princeton. Um instituto criado em 1930, recebeu Einstein, Newman e tantos outros que, refugiados da Europa, foram para o Institute of Advanced Studies. Foi aí que o ponto mudou, que houve o shift entre a Europa e os Estados Unidos. Foram esses que criaram a América Grande. E, portanto, eu acho que, ao não contarmos essa história, nós estamos realmente a não fazer o nosso trabalho como políticos e também como cientistas. Essa é a única maneira que nós temos para o futuro e eu espero ter sido, de certa forma, parte de vos contar essa história. O Jonathan Sacks, que eu gosto muito, um grande filósofo britânico, tem uma frase que eu acho que nos cai aqui como uma luva. Ele dizia: quando contamos a nossa história, a nossa identidade fortalece e estamos dispostos a receber os outros, os estrangeiros, de braços abertos, porque não temos medo. Contamos a nossa história. Quando paramos de contar a nossa história, a nossa identidade enfraquece e sentimos-nos ameaçados. Temos medo do estrangeiro. Por isso, lutem sempre como cientistas, porque, para mim, lutar pela ciência é lutar pela democracia. Muito obrigado.